and sharing. Okay. And today we do a review for the midterm. And announcements. First announcement, of course, the midterm. Term is on Monday, 12:30, March 1st, let's say. March 1st at 12:30 p.m. And two, I heard a lot of complaints over the past 2 weeks that students having multiple midterms, some of them around the same time. And I sent you last week that you have to contact me beforehand to tell me exactly and show me that you have another midterm. I did not hear from any students. So I expect all of you to be in to come to the exam at 12:30. So no one.
Professor?
No, please. Don't, yes, don't tell me now that you have another exam. I ask you to send an email.
Oh, no, I wasn't saying that.
Okay, so let me finish my announcements and then you I will let you speak. Okay. Okay. No. No one sent emails about same exam timing. All expect to attend. If you have any special requests or special needs, let me know. I was attacked by one student. If you have any special need other than extra time, please let me know.
An email?
Yeah, I said in my announcement that anyone, if you need just extra time, you have a certificate from the student special needs that you need extra time. That's fine. We'll let you stay. Anyone, yeah, we'll let that student stay for extra time. If you need any other arrangements, let me know.
Yes, doctor. Thank you.
Okay, sure. What else? Midterm, Kazan. No one special. Okay, I think that's it. Yes, if you have any questions, let me know before I start. Anyone has questions?
Professor, I've just been quarantined recently. 2 days ago, 3 days ago.
You sent me an email, right?
So should I send you my itiraz and my letter?
Send me the sick leave.
Professor, yeah, it's Professor. Sure. The sick leave is the one you need, right?
I need the sick leave that it shows that the sick leave I received a sick leave from a student showing that he was exposed and he's not fit for 14 days. So I need that one, right?
Yeah, no, I'm just double checking because my previous professor like shouted at me because I showed him the letter. He said it's fake.
I don't know. I will trust. If I suspect, I will report it. But other than that, if you are sure about your certificate, just send it to me. Okay.
Professor, the UIN numbers are there usually. You can just search them on. You can just call the hospitals even and check. That's the thing.
I will not search. I mean, rule that the sick leave certificate is the rule. If for any reason I
Yeah,
suspect it,
it's
I
a
will report you, and
certificate, the sick leave certificate,
okay?
and the taraz. Yeah.
Why do you ask the same question many times? Send what you want, please.
Okay. Okay.
Okay. Okay. Once you are done, we'll do the exam. Once you finish the quarantine.
Doctor?
Okay. Yes, Abdullah.
How long is the exam?
Well, an hour and a half. 12:30 to 2.
Okay.
Okay. Sure. طيب. So what the plan for today is, I uploaded a sample exam for you. I think that exam is a bit on the hard side. It's not, yeah, probably it's a bit harder than what I plan to give you. So I will solve today a more typical one. Probably I will get something in between today's one and the one that I posted. So let's start with the exam. This problem 1, and this do 1.1. And this problem, this kind of problems, I did not solve with you in the lecture, so I thought I should do one with you here. I gave it to you in the homework.
Doctor,
Yes.
can you repeat the last part? You said the exam will be harder than the typical one, or I get confused on that.
No, I said the exam that I uploaded is a bit harder than what I plan to give you. Okay, the one that was uploaded, sample exam that was uploaded. Okay.
Okay.
Fine. So for sure we will have part of a problem to ask you about a network like this, and we'll ask you about whatever the probability of the circuit operates or the circuit fails. So in this case, I'm asking probability of operation, where in each probability of failure is given inside each device, and devices fail independently. Okay, so to solve this kind of problem, you need 2 rules that you need to always remember. First rule is, sorry, it's wrong. Rule 1, for devices parallel, it's easier to calculate the probability of failure to find the equivalent. So if we take, this is point 1 and this is point 1, and I want to find the equivalent of this circuit. Let me call this device A, this device B. So probability of failure equals the probability that this overall circuit, the equivalent of those two in parallel, this circuit will fail only if both A and B fail, right? So the probability of failure is the probability that A fails and B fails. So this is the only way that I will not have a line from left to right. So this if we go up to the original circuit, when will this operate? It will operate if I have the one on the top working well, or the one on the bottom with the one on the top, or the one on the top with the one on the bottom, or the one on the bottom with the one on the bottom, or all of them. But at least I should have one in each stage. However, if I have two, the probability of failure is if both fail, that will cut the line from input. If you call this input, and if you call this output. So probability of failure is probability of A fails and B fails, which is probability of A intersects B, and since they are independent, it's probability of A times probability of V, which is 0.1 times 0.1, which is 0.01. So the equivalent is one device that has a failure of 0.01, which tells you about the reliability of this system. If you put two systems in parallel, each with a reliability of 90%, if you have two of them in parallel, then the overall reliability will be 99%. If you put three, it will be 0.1 times 0.1 times 0.1, it's 0.0001. So the reliability is 99.9%, right? And so on. The more you add in parallel, the better is your reliability. Why? Because you always have and the chances that all of them will fail at the same time is little, and then this will improve your reliability. Yes, Abdullah.
Doctor, 0.1 is the probability of success or fail?
Failure, that's what I said in the beginning. Probability of failure is given inside each device. See, here I give it.
Okay.
Okay. Right. So if you want to calculate the probability of let me note before we move to the other one. So calculating the probability let's probability, why I wrote it this way. Probability of operation is hard, as we have three scenarios. We have three scenarios for operation. If we have devices in parallel, like A operates, or B operates, or both operates. So to calculate the equivalent operation from the original circuit is hard. It's better to do the equivalence of one circuit, and then you can calculate the operation from the equivalent circuit. Right. So the second part of the system is the same, right? So I can have the overall system, so the equivalent system is like this. Which takes me to rule number 2, which says that for devices in series, it's easier to calculate the probability of operation. Again, because we have one scenario for operation only, which is both operates. So if we call this C, this is D. So probability of operation is the probability that C operates and one second, Musab, and D operates, which is probability of C intersects D, which is probability of C times probability of D. But what's probability of C in this case? Talking about probability of operation. So probability of operation of C is 0.9, and probability of operation, or let me not to confuse you, can just write it. It's 1 minus 0.1 times 1 minus 0.1, which is 0.9 times 0.9, which is what? Or maybe you want to tell me about this 0.01. شباب نايمين انتوا اليوم. This should be Musab, go ahead. You want to tell me about this?
Yes, Professor, that one.
Okay, so, thanks. You all sleeping except Musab. 0.01 times 1 minus 0.01, which is 0.99 times 0.99, which is 0.98. So the overall reliability of the system is 0.98. I can ask you also, what's the probability of failure? Abdullah, go ahead.
Professor, I remember I faced a question which was about the operation, but it was the sum. So I get confused now. When do we sum or add probabilities, and when do we multiply them by each other?
If they are independent, if you have two events that are independent and you are calculating the probability of the intersection, it's the product. So if in this question I did not tell you that they are independent, you would not be able to do this. You will not be able to solve it.
So if they are independent,
so this is all based
I multiply them.
Yes.
But here you didn't say so. By default, I multiply them.
No, it says. I went step by step. I'm just writing down and then I calculate the probability. I said, what's the probability of operation? It's probability of C operates and D operates, because the system, for this to have a line from the input to the output, both should be operating, right? At the same time. So probability of C operates and D operates. We know that D and is an intersection operator. So it's probability of C operates, intersects, probability of D operates. And since they are independent, then the intersection becomes a product, and then you just multiply. Okay. So if I ask, what's the overall probability of failure? Yes.
And regarding the whole system, you only find the probability of one parallel boxes fails. So, for example, if we
no, I found both because both are the same. So I did not repeat. This part is the same as this part. So each
Okay,
one
but
gave
if
me
they are
one box.
different, I multiply them.
If they are different numbers inside them, you have to calculate for each one.
And then to find the total, I multiply them, right?
Yes. Yes,
Okay.
to find the probability of operation. Always start with, always try to write down what you want to do. Here I'm interested in probability of operation, so I write it down, probability of C operates and D operates, and then this is the intersection and says they are independent, the product, and then I then start putting numbers. Don't start by putting numbers. Just write down what you want to do. I'll give a quick example now. I'll solve it fully. I will let you know. So if the probability of failure is 1 minus probability of operation of the system, so 1 minus 0.98, so 0.022% of the time this system will fail. On the other hand, if I give you something like this, okay, I give you something like this. Again, probably 0.1, 0.1, 0.1, 0.1. And I ask, what's the probability of operation of the system? So in this case, the way you need to start is you need to start with finding the equivalent for this and the equivalent for this, right? So if you call this A and B, so we have 0.1.
And then, doctor, you do
0.1.
one for the overall,
So,
like A, B, and C, D.
yes, you do the top part and then the bottom part, and then you will end up with 2 in parallel, and you find the result from them.
Doctor, this is like electrical circuits now.
It is, and all courses are connected. So what's the equivalent of this? For series, we said, what's the best way of series? To do what?
Success.
So, yes, or operation, success or operation. So it's 1 minus 0.1 times 1 minus 0.1, which is 0.9 times 0.9, which is 0.81. So you'll end up with 0.81 parallel with, and don't get confused between failure and operation. And you keep track of what you are writing inside it. If you want to be consistent with, you are just putting the failure inside, and this should be 1.19 and then 0.19. And then for this parallel, you can calculate the failure, which is 0.19 times 0.19, and you find the result.
0.0361. 0.0361.
Okay, that's fine. Okay. So this was problem 1.1, part 1 of problem 1. So usually, as I said, the first problem is small problems like this. 1.2, it
Doctor?
says you are asked to throw a dice until you, yes?
Sorry, can I ask something about the previous question?
Sure.
So, doctor, you have 2 paths, 0.9 and 0.9. Either one of them should work. So, is it possible? Isn't the possibility should be 0.9 union 0.19? No, it's not intersection. It's either this or this.
Which part you are talking about?
For the parallel,
Which part?
not series. The parallel.
Type. Okay, let's 1 second. So we said in parallel, it's easier to do the failure.
Okay.
If you want to do the parallel, to do probability of operation for the parallel, probability of operation, let's call this device 1, device 2. Probability of operation is probability of 1 operates or 2 operates or 1 and 2 operates.
It gets more
Right?
complicated, yeah.
Okay, now it makes
So
sense.
you need to calculate
Yes.
all scenarios. You can do it this, but it's long, and you need to make sure that you are subtracting any intersection that might happen, because even if they are independent, they might be intersecting with each other. So again, for the parallel, just do the favor, because you have one scenario only.
Okay, تمام.
Okay. Right. Second question was asking about you are asked to throw a dice until you get the number 1. What is the probability that you will get number 1 in the 5th trial? Throw a dice till you get number 1. Find
To infinity.
probability of getting 1 in the 5th trial.
So this one is the both
First of all,
universals.
what type of distribution is this?
It's something raised to 4 and then
Poisson, right?
No, which distribution?
Poisson?
Which distribution? I'm telling you, keep throwing. You throw the dice, keep throwing the dice until you get 1, and then خلاص. Stop.
Bernoulli.
Bernoulli, doctor. Bernoulli.
Geometric, I think it's geometric.
Geometric, yes.
Binomial.
Bernoulli, doctor.
No,
Right.
geometric.
Binomial, sorry, binomial.
Okay,
binomial.
let's. طيب شباب. First of all, I hear someone says Bernoulli. Bernoulli, it's not a distribution. Bernoulli, we say just it's Bernoulli trial. Bernoulli trial is whenever you do a random experiment that can have success or failure, we call it a Bernoulli trial. But the distribution that we talked about, we have binomial, we have geometric, we studied Bernoulli, geometric, Poisson. What else? We did one more.
Binomial.
Exponential.
Binomial, geometric, Poisson, and uniform. Yes. So which one of those? So again, binomial, you have fixed number of trials, but the success is random. Geometric, you have number of tries is random because you keep trying until you get a success, which is what we are doing here, right? I'm asking you to keep throwing the dice until you get a 1. So this is clearly a geometric distribution.
The number of trials is fixed. He said 5th time.
No.
5 times.
This is what I'm asking for. But the question is, in the exam you'll have a longer written question. Throw a dice till you get number 1. If it is fixed, there is no meaning to ask you what's the probability that you will get in the 5th try you will get a success. If it's fixed, it will always be 5, right? So this is a geometric distribution. What's the probability?
If he said in the question, if he said in the question, what is the probability you get 1 in the 5th trial? It will be the same. That's what you mean, right?
Yes.
Okay.
Binomial, if I'm telling you this, you throw a dice 10 times. Go and throw, if I tell you, go and throw a dice 10 times. What's the probability that you will get 2 ones out of those 10 tries? What's the probability of you getting 5 ones out of those 10 tries? This will be binomial because the number of tries is fixed, 10. And what's random is getting the success that we are interested in. But here, the way I'm telling you is to keep throwing the dice until you get number 1. So it's geometric because you keep trying until you get your success, which is getting number 1 is the success that you are looking for. So in each trial, what's the success? What's the probability of getting a 1 in each trial?
1/6.
1/6. Do you all agree? Probability
Yes,
of success in each trial is 1/6, which is getting number 1 in throwing a dice. So خلاص يعني once you figure out which distribution and what's the parameter, you just go ahead and solve. So this is 1 minus p to the 4 times p, which is 1 minus 1 over 6 to the 4 times 1 over 6, which is 5 over 6 to the 4 times 1 over 6. Then I ask, what is the average number of trials to get one?
Six.
What is the average number of trials to get one?
3.
Let me tell you something. In the exam or in quizzes, or it's not necessarily that I will always ask you find the mean, calculate the mean. If I tell you what is the mean, or what is the expected number, or what is the average number, of this I'm asking, it's like I'm asking calculate mu. I might ask about calculating mu in many different ways. What's the mean number of trials to get one? What's the average number of trials to get one? What's the expected number of trials to get one? It means that calculate mu, which is expected value of x, which is for geometric 1 over p, which is 1 over 1 over 6, which is 6 trials. Okay? So don't expect each question to be very straightforward. Just focus on the meaning of the question. So this is, we are still in part 2 of question 1.
Doctor, can I ask you a small question? Sorry.
Yes, small question.
Doctor, so in this one, we ensure that the first 4 trials we did not get one.
Yes, you get any other number, but not one. Then you got one at the 5th, and then you stopped. Okay?
Yeah, clear, doctor. Thank you.
Okay. Right. Well, 1.3, I think we did this in the class, but I asked about car plates in Qatar. In the past, it was 5 digits. Then now we moved to 6 digits. How many? And the question is, how many new plates were added by moving from 5 to 6? How many new plates were added by moving from 5 digits to 6 digits in car plates? So the number of digits again. How many plates?
Repeating or not repeating?
What do you mean repeating or not repeating?
As in the same number, can it
How
be
many
repeated?
different plates I can generate? How many different plates I can generate with 6 digits? Each one can be from 0 to 9. Right? In Qatar, we use just numbers.
10 power 6 minus 10 power 5?
No, I need the new ones, only the new ones. This is simpler question. So the new ones is just
900,000.
no, it's 10 times 10 times 10. This is all 6 are new ones, right? We did not have 6 before. So simply 10 to the 6. This is the number of new ones. what's the total number now? If I ask what's the total, what's the new total? New total, again, assuming 2 digits, you said, or 3 digits? 3 digits minimum. Minimum. Then this is 10 to the 3 plus 10 to the 4 plus 10 to the 5 plus 10 to the 6. And if I ask, I don't usually ask the same question twice, but if I ask this question, I might ask some tricks. Like also assuming the first digit on the left cannot be 0. So if the first digit, so if assuming left digit can't be 0, so the new number is what? New number is, so for the first digit we cannot have 10. So it's 9 times 10 to the 5.
Yes.
And if you include number, if you include letters, and so you are now, I guess, professional in doing this. So you don't need to elaborate a lot on this question. 1.4. 1.4 is a bit tricky. Probably the only tricky question, and it's not that tricky. The whole exam, probably this is the small trick that I used. I was so kind in 2018 when I gave this exam. So it says that if probability of A equals 0.5, probability of B equals 0.6, and the question is, can A and B be independent? Mutually exclusive.
We have to do the 4 rules.
So I'm asking, okay, so yeah, that's, I like when someone says let's check the rules, because if you go and work according to the rule, you will not make a mistake. So the best thing here is to check the rule. So let's start with the first one. So for independence, the rule is probability of A intersects B equals probability of A times probability of B, right?
Yes, sir.
So is probability of A intersect B given? It's
No,
not given.
it's
I'm
not.
just giving you probability of A and probability of B. So it's 0.5 times 0.6, and this is 0.3. So the perfect way to answer this question is they can be independent. Probability of the intersection equals 0.3. Otherwise, they are not.
Small question, doctor.
Yes.
Doctor, can you confirm that by saying that by checking probability of A union B and doing probability of A plus B minus probability of A intersection B, if it's not equal to 1, then it means something, I guess, or no?
But you don't know probability of A union B, and you don't know probability of A intersects B. You are not given. You are just given probability of A and probability of B. So you have to deal with the information that is given to you. Type. For mutually exclusive,
The sum must be equal.
what's the rule?
The sum should equal 1.
Probability of A union B. This is the rule. Probability of A plus probability of B, right? This is the rule for mutually exclusive.
Or
So
probability
from
of
the
A
question,
given
we know
B.
that this is going. Probability of A
Prob-
intersects B is 0.
No,
Right?
probability of A,
That's
yeah,
right.
and probability of A given B is equal to probability of A.
No, this is for independence, not for mutually exclusive. Probability of A union B is probability of A plus probability of B. So if you do this, if you add them, this will be 1.1, which is greater than 1. So what does that mean?
They cannot
They
be
can't be.
mutually exclusive.
They cannot be
They're
mutually
independent.
exclusive. Correct. They cannot be mutually exclusive. They should have intersection so that we have to subtract something to drive the probability less than 1. They cannot be mutually exclusive. So this is the only trick that I had in that exam, which will not be the case for you guys. Abdullah, go ahead.
You can bring the same question, doctor, no problem.
I can bring the same question, خلاص. I promise I will do something close to this. I did not put the exam. Usually I put it 1 or 2 days before the exam. I will keep your suggestion in mind, but don't regret it.
Same, I mean same.
Okay, same, no, same, صعب same. It's, okay.
Doctor,
So Shabab,
it should
get
be-
into your blackboard to
Doctor,
hmm?
it should be 1 or less, right?
Yes.
Not 1.
It should be
One
1
or
or less.
Okay.
So if I give you the same question and the addition was less than 1, can you say that they are mutually exclusive?
They can be, but
They can or cannot
No.
be. We don't know, right?
No, they should equal 1. If they're less, then
How can
طيب
how
شباب
can
شباب
they
I
not
started
be exactly one?
شباب I started the attendance. Please go to Blackboard and check in your attendance so that you don't tell me after that I missed it. So go and check that. We'll pause for a couple of minutes and then we'll continue. Oh, sorry, my iPad. So I start sharing again.
Yes, doctor. Can I ask you?
Sure, go ahead.
You said the number should be exactly 1 or less. Cannot be more than 1. How can it be less than 1?
If I tell you the question, probability of A is 0.2, probability of B is 0.3. Can A and B be mutually exclusive? What will be your answer?
I mean, shouldn't they all equal 1? Yeah, that's what I know. All of them should equal 1. Unless there is a third possibility, like C, for
I'm not
example.
telling you that A and B are the only events that we have. Did I say? And always
Okay.
don't assume
Okay.
things that are not given. To
Okay,
be on the
okay,
safe
tamam,
side, don't assume things. Or if you want to assume, tell me if the question will be wrong if we only have A and B and they don't add to 1. Okay? Can you see my screen?
No, doctor, we cannot.
We don't.
No? Okay, sorry. Okay, share screen, start broadcasting. Okay, I think now you should.
Yeah, now we can see it.
Okay. Type. So attendance is closing in 15 seconds. So make sure that you cast in your attendance. Okay. Problem 2.
Doctor, what's the answer?
What?
For,
They cannot be mutually exclusive.
if
They
it's
should have
less
something
than
in
one?
common, because they add to more than one. So they should have something in common. They have intersection, and if they have intersection, they cannot be mutually exclusive.
I mean for -1, for less than 1.
If I give you A was 0.2, B was 0.3, and I ask you, can they be mutually exclusive? You if I'm in your place, I'll say they can or cannot be. We don't know. If their probability of union equals the sum, then they are mutually. If probability of A union B equals 0.2 plus 0.3, then they are mutually exclusive. That's
Doctor,
the way I will answer it.
Doctor, should we do this for all the rules that exist? We should show for all of them, or just by one rule we should decide?
No, we said for independence, the rules are equivalent, so one of them is enough. Same for mutually exclusive. So if you can use either probability of A intersect B equals 0, or union B is A plus B. Okay. So problem 2, I'm giving you a discrete random variable. Probability of x equals x is just x over t, where x equals 1, 2, 3, 4, and I'm asking you 2.1, what value of t makes this a valid probability mass function? What's the value of t that makes this a valid probability mass function? So let's see. So if you have this x, and here f of x, so 1, 2, 3, 4 x. What's this? This is 1 over t, 2 over t, 3 over t, and 4 over t, right? So to be valid, we have two conditions, right? F of x should be greater than or equal to 0, which means in this case, t should be positive, right?
10.
Yes.
The second condition is that the summation
Sum is equal 1.
be 1, which means that 1 over t plus 2 over t plus 3 over t plus 4 over t should be 1, which means 10 over t should be 1, which means that t equals 10. So
Doctor, can we type the rules in the paper, because we might forget them,
Then you are allowed one A4 paper double-sided to write anything you want, anything.
Even the rules, that's fine.
Even it's mainly for the rules. What else you will write? Your CV.
Okay.
You have rules or questions that if you want.
I
Yes.
said maybe you will find it something written and you will say that's cheating or something. Just wanted to make sure.
No, there's no. Anything on the piece of paper is not cheating. Anything on your hand, your toe, and your hand will be cheating. But on the piece of paper, no.
So doctor, just to be clear, anything we can write on the paper, right? Anything on two sides of the paper.
Anything.
Okay.
Anything. Don't write. Be smart. Write anything. No, just write. Useful.
Doctor, I don't like it when you say anything. It makes me feel that you're sure the exam will be tough and nobody will get the chance to cheat.
No,
I know, right?
No, it's an exam and should measure your ability to solve problems within the resources that you have. And you will always have resources in real life to solve problems. So it's the challenge for you to pick your resources. What resources you will have? You have limited resources. One page, you can write whatever you want. It's fine. If you write one problem and you can use that solution to solve a similar problem, that's you are a good student, right? Okay.
And
exactly.
the size does not matter, right?
What?
The size of the writing does not matter, right?
Does not matter. Use 0.5 millimeters.
You already said it's fine.
Put anything you want
You
يا
said use
ماجد.
any font you want.
خلاص شباب خلاص. Okay, that's fine. Whatever font you want, whatever, it's one paper, two-sided, so write whatever you want. Find capital F of X and plot it. So let's plot both small f of X and capital F of X. And then we write down f of X. So this is X, this is small f of X. And we have 1, 2, 3, and 4. So at 1, it's 1 over 10, 2 over 10, 3 over 10, and 4 over 10. So let's write it. So this is 1 over 10. At 2, it's 2 over 10. 3 is 3 over 10. And 4, sorry, 4 over 10. So this is small f of X. What's capital F of X? Let's try to plot capital F of X. Let me use the red. And again, let's have this is 1, this is 2, this is 3, and this is 4. And as we said, we start f of X from the left and we go to the right. We know that at 4, and we know the end, it should end at 1. And we know the start, it should start at 0. And as we move from left to right, we just accumulate or add probabilities as we move. So each one, how much probability do I have at 1? I have 1 over 10, so I jump to 1 over 10. I carry it on my shoulder, and then I keep moving till I reach 2. At 2, I will add 2 over 10. I already have 1 over 10 in my bag, and I add 2 over 10, so I jump to 3 over 10 and continue till I reach 3. At 3, I will add 3 to the 3 I have, so I jump to whatever, 6 over 10. Continue moving until I reach 4. I add 4 to the 6 and I jump to 1. So the check for you, you should end at 1 and you should start at 0. So now you need to write it down. You need to write the equation for f of X. So it's 0 when X is less than 1. Between 1 and 2, it's what? 1 over 10. When X, and for discrete, less than or equal is different than less than. So you have to be careful. So it's less than 2, greater than or equal to 1, because at 1 it's 1 over 10. Then 3 over 10 when X is less than 3, greater than or equal to 2. Let me continue here, and it's better for you to write it in 6 over 10 when X is less than 4, greater than or equal to 3, and then 1 when X is greater than or equal to 4. This will be your capital f of X. You can also calculate the mean and the variance. Calculate mu and sigma square very easily. You just apply the rule, summation x f of X. Then it is 1, whatever, not summation anymore. We'll just write it down. So 1 times 1 over 10 plus 2 times 2 over 10 plus 3 times 3 over 10 plus 4 times 4 over 10. If you do this, you will get 3, I guess, according to my notes. And the variance, try it yourself. You should get 1 in calculating the variance. Okay. Let's do problem 3 because we are running out of time. Problem 3, it says that HMC, Hamad Medical Corporation, tested 100 people for diabetes and measured their weights. And what we got is something like this. So we have overweight, normal, diabetes, no diabetes. So out of those 10, 55, 5, and 30, total is 10. So let's say D is the event of having diabetes. And O being overweight. The first question, if we pick someone
You mean
random
total is
out of those,
okay.
yes, if we pick someone and random out of the 100, what's the probability that that person will have diabetes? So having diabetes is
0.65.
65 over 100.
65 over 100, which is 0.65. What's the probability? Let me check what's the second question. Okay, second question is, if a person is overweight, what is the probability that he or she has diabetes? So you went to that group of people and you picked one who's overweight out of the 100. So we know he's overweight. What's the probability that
55
that person will
over
have
60.
diabetes? So we apply the rule again. So probability of, now we are asking of D given O, right? Probability of D given O is probability of D intersect O over probability of overweight. Probability of overweight, overweight is this. And what is the probability of intersection of D and O?
0.55.
So the here is 55 over 100 divided by what? 60 over 100, which is 55 over 60. Right. 3. From the events, are the events of having diabetes and being overweight independent? Are D and O independent events? You can tell this right away from the previous two questions.
No, doctor.
Yes, now we have many conditions for independence. You can check. General rule for independence is that D intersects O equals probability of D times probability of O. Or since we have probability of D given O. So if probability of D given O equals probability of D, then they are independent, right? This is one of the rules of independence. So now we know probability of D given O, this is what? 55.
And also the vice versa.
And yes, yeah, any one of them. But for those two, we have the probabilities already. So are these equal? No, right?
No.
Which means the events are dependent. Okay? Last question in that exam was easy also. Problem 4. I think that exam, at that time, I gave 2 midterm exams. That's why there's no continuous distributions or continuous. There's nothing about continuous. It's only discrete. So
By
in
the
your
way,
case,
this is different than the one you uploaded.
different. Yeah, this is different. And I found this, Saraha, just yesterday. So I thought this is different. You have that one, you can read it yourself, and this is another one. Problem 4. It says the number of customers arriving to QMB Qatar University branch is known to follow a Poisson distribution with average of 5 customers per hour. Customers arriving to QMB QU is Poisson with lambda is 10 customers, 5 customers. Lambda is 5 customers per hour. And the first question is, calculate the probability that exactly 5 customers arrive in a period of 2 hours. Exactly 5 customers in 2 hours.
Change
Again,
the lambda.
the only thing we said we have to be careful with in Poisson is to check the time period. What time period we are talking about? What time period the question is asking about? In this case, he's asking about hours time period, right? So the probability, so lambda equals, we know 5 customers per 1 hour, and at the same time it equals 10 customers in 2 hours, right? Do you agree?
Yes, sir.
So now he's asking about probability of x equals 5. We know that Poisson e to the minus lambda, lambda to the x over x factorial, which is simply e to the minus 10, 10 to the 5 over 5 factorial. And you can leave it this way in the exam if you wish. You can calculate it. It's up to you. Okay, 4.2. What's the probability that a day passes without any customer coming in, where QMP opens between 7 and 1 p.m.? Probability of 0 customers in a day from 7 a.m. to 1 p.m. So what's the new time period? Five plus 1, 6 hours, right? So what's my new lambda? So if in 1 hour we have 5, in 6 hours we have 30 customers per 6 hours. And then I'm asking about probability of x equals 0, no customers whatsoever. So e to the minus lambda to the x over 0 factorial, and then the answer is e to the minus 30, which is very low number, extremely low number.
Very small possibility.
And it makes sense, right? And if they usually they get every hour they get 5 customers, it's very unusual that a whole day passes without any customer coming in. Okay. 4.3. Very simple question also. Customers you expect to arrive in a period of 3 hours. Again, you expect means that, like, I'm asking about the mean. Mean is just lambda, and lambda for 3 hours is just 15 customers per 3 hours. Okay. And of course, I in the exam that I uploaded to you, it connects the Poisson with exponential. If I ask you about Poisson, most probably I will link it also to exponential, because we know the time between customers is exponential, right? So, and one thing for sure, in the midterm, for sure, I will ask about normal distribution. And one thing about the normal distribution, I think it's in your book. I did not mention that explicitly, but sometimes I remember in the past I asked about it. Let me just pull it up. So we have 5 minutes. Let's do 1 second, because I don't memorize that. Where is it? Okay, 1 second. Okay, system, okay, connection loss, and then I need 4, I guess. Yes. For normal distribution, it's known that, okay, for any normal, probability of x to be between mu plus sigma and the mu minus sigma, this is always 0.6827. So if you plot any normal distribution, this is mu. Then if you take mu plus sigma and mu minus sigma, this area is 0.6827, regardless of what is mu and what's sigma. We also know that probability of x between mu plus 2 sigma and the mu minus 2 sigma, this is always 0.9545. So if you plot mu plus 2 sigma.
Are these given values ولا يعني is it always like this ولا
It's always like this for any mean and any variance.
same numbers كمان?
Same numbers, yes.
Okay.
So this is 0.9545. And finally, can write another color, maybe. Let's do green. Probability of mu minus 3 sigma less than x less than mu plus 3 sigma. Of course, if I ask you this with numbers and you don't know those rules, because you can use the table and you will be able to find it. I'm just giving you a hint to.
But doctor, if you gave me this, I don't have to prove it, right? With numbers.
No.
I only mentioned this and that's it. Okay.
Unless I ask you to prove it.
It's a rule يعني. It's a rule.
يعني I might have change of hearts and give you proofs in the exam. Can somebody blame me? No.
يا رب لا يا رب لا دكتور.
Okay, so this is a fact known for the normal distribution. Keep it in mind. The probability that the value of the normal distribution is within one standard deviation above and below is always 68.27%. Okay, so I think I will stop at this point. If you happen to have any questions tomorrow or Sunday, please let me know. We can send me by email. If you want to talk, we can talk. I'm fine. I'll be available even in office on Sunday and tomorrow. I'll be in office starting around noontime all the way to like 4 o'clock maybe. So let me know if you have questions. Somebody raised hand. I missed the name. Go ahead. Who raised your hand? Yes, go ahead.
I wasn't able to check in for the attendance. Closed.
Yeah, you have a bad luck. Sorry.
Okay.
I wish you good luck next time. Just خلاص, if you missed it, خلاص. What can we do? This life, sometimes you miss opportunities in life, right? طيب. Any other question? طيب شباب, good luck in the exam. Please study well and wish you all the best. Don't mix with someone so that you go into quarantine. Yeah. Wish you a safe end of week and wish you all good luck. Yeah. Assalamu alaikum.
السلام عليكم.